And so with that, I'd like to, again, welcome everybody. This is our 11th year of the River Herring Forum. We are really grateful to our presenters who are offered to present this time. If anybody would like to contribute to the next meeting, just so you know, it's on November 3rd from 1 to 4 p.m. on a Monday, as always. And just let us know, email me or Jonathan with your ideas, and we'll get that agenda sorted out in the future from now. With that, I'm going to pull up the agenda and roll right into our first updates. Give me one second.
While you're doing that, James, I'll just say, we try to, we'll send out the call for presenters, about 2 months, month and a half ahead of the next meeting. So sometime in late September or early October. But if you've got, information that you want to share with the forum throughout the year, please, send it to us as well, and we'll redistribute it. As you guys all know, we regularly send out updates and are happy to include, calls for information, or you want to share recent news stories or updates with the rest of the forum, please, send them our way, and we will work to get that out and serve as that source of information for the rest of the forum. So thanks.
Thanks, Charlie. First update, so we have from the commission's point of view, the management side of River Herring, Shad River Herring has been a little quiet lately. They have not met since the October meeting, but we have had 2 meetings of the Shad River Herring advisory panel since then. They reviewed the River Herring benchmark stock assessment, which we talked about at our last meeting. So that the summaries for those meetings should be up on our website now. If you'd like to check that out, any other questions about that can always be addressed to me, and we're happy to talk more about that. So other than that, that's all that's going on for the moment. With that, I'm happy to move on to, unless there's any questions, I'm happy to move on to Jason Didden for the Mid-Atlantic update.
Okay, well, I'll go. This is Jason. Pretty quiet at the council also, but I'll flag a few things. So the council will be setting Atlantic mackerel specifications later this year for 2026 and 2027. We'll have a new assessment for mackerel, and that will get reviewed in the summer. And then when we set mackerel specifications, I create what the council calls its River Herring and Shad update, which is kind of a series of questions that council, River Herring and Shad committee years ago kind of thought would be useful to think about when the council is deliberating on what to set for a cap. So I'll produce that probably for the August meeting, and then the council will get the mackerel assessment results and set the mackerel quotas, and at the same time set any River Herring and Shad cap. We don't have the results of that assessment yet, so it's hard to know, whether or not there may be a mackerel fishery is really not currently for 24 or 25. If you look on the mackerel quota monitoring webpage, there are like a couple weird jumps in June and like late June and early August. There's some like weird Maine state data in there, so that's going to get revised. If anyone happens to be, you'll see these like big jumps in the quota monitoring, but I think that's some phantom fish there that will get adjusted in some fashion. So the basically at an incidental level of mackerel landings currently is all that's allowed given the very low quota. So that will be some management processes. The council also has contract work with Janet and I at University of North Carolina, trying to extend some of their previous spatial environmental risk modeling work that had been done that this group, I think, talked about at the last meeting. And so we're starting to talk to some industry folks to try to get some input on like what, and they're going to be talking to them more about like just in terms of like the logistical operations of some kind of app or something to try to get some and so they'd have like get some input first on the logistical side of what might be useful for an avoidance thing, and then they'll move into more of the modeling part of the project, and hoping there's either some enough herring or mackerel quota next year to then get input from fishermen on using this kind of on a voluntary basis some risk profiling information to try to stay away from river herring and shad. And that's if you go on the council's website um, and look under science and research, then climate, all of our the council's got some grant monies, and we have a variety of projects focusing on kind of adaptive management and dealing with shifting stocks and governance issues. But one of the early projects was this river herring and shad kind of environmental modeling one, and you can read some more there. If you go to the council site, there's a link to a description for a little more detail on the projects. So that will be spinning up kind of as we go through this year. And I think that's all I have.
Thanks so much, Jason. If there are any questions, feel free to raise your hand. Not seeing any. Next, then we'll pass it on to Jamie for the New England update.
And I'll just add, I have a longfin squid research track working group modeling meeting this week, and so I have to drop off. But definitely, please, kind of just if folks can note if there are any other management things come up. I'll definitely look at the summary when this comes out, but I'm going to have to drop off. So if there are some management questions that pop up, I can just follow up later.
Thanks, Jason. We did get one question into the question box if you have 1 minute, otherwise.
Yeah, sure.
It's Jason. Have any of the council's projects been impacted by grant freezes?
None of the Mid-Atlantic Council projects have. They're all proceeding as planned. As far as I'm aware, I'm not involved in all the projects, but I think for our projects so far, they are proceeding as kind of initially planned. So that, I mean, certainly there's some uncertainty there, but but nothing so far that has kind of changed direction. I think some of the councils may have had some issues with these grant projects, but so far with us, we're kind of proceeding.
Thank you. Can you hear me okay? I had to sign out and sign back in.
Yep.
Okay. Thank you. And thanks for the opportunity to provide a brief update. I'm Jamie Cornan. I am the council staff lead for Atlantic Herring at the New England Fishery Management Council. Just a real brief update on a number of things. So 3 things. First, the catch limits for 2025 and the current activity in the herring fishery. Second will be an update on the council's work on Amendment 10, very brief. And the third will be the next opportunity to hear about the work on Amendment 10. So last time we met, the council was working on setting its specifications for Atlantic herring and river herring and shad catch caps. The council requested an in-season adjustment for 2025, which significantly lowered the catch levels for Atlantic herring due to the recent stock assessment. And so those are in place now. You can find details about those values on our webpage as well as Garfo's. And in-season data into the first part of this year, we already have 2 areas that are under possession limits for herring. So they're under a 2,000 pound possession limit. That includes Area 1B, which is in the Gulf of Maine, and Area 3, which is largely Georges Bank. Area 2 is open, and Area 1A will open later this year. So the fishery is working under very low catch levels. The council decided to revisit these quotas, and they'll be doing so at their April meeting, which is in Mystic. And at that April meeting, they're going to look at some new information from both the plan development team and ASMFC's technical committee, as well as our scientific and statistical committee. So they may decide to revise the quotas based on the new information, and that would be for Atlantic herring. The second part is Amendment 10. The council received an update on this work at its January meeting in Portsmouth, New Hampshire. And Amendment 10, if you recall, is the one where the council is looking to minimize user conflicts in the Atlantic herring fishery, support rebuilding of the resource, and address river herring and shad catch. We plan to have one more update coming up soon on this action in June. At the April council meeting, we will not be providing an update on Amendment 10, and that is so that the technical teams can present their work on the potential updated specifications. So we've made some progress on Amendment 10 through our plan development team and committee work, but that's being put second right now to work on the specifications, and we'll pick that back up again after the April council meeting. So please, if you're interested in tracking what's going on with the river herring and shad work, please come back to our June council meeting, which will be in Freeport, Maine this year. And I can take any questions if anyone has any. Thanks.
Jamie, thanks for presenting. I did that press release that you sent over our way earlier today. I just put that in the chat for folks who are interested in the latest happenings at the council. So just wanted to flag that for folks if they were interested in learning more.
Excellent. Thank you very much.
Okay, is that I think that wraps up the first part of the agenda, the management update section. As always, yeah, thanks to everyone for keeping us all up to date and what's going on with the at-sea management. Really appreciate you guys all always showing up to the forum to provide your expertise and insights. And we'll continue to try and keep sending those updates out as they're available, press releases and things to the forum throughout the year as I can keep track of them. So with that, we will move into our technical presentations section of the forum. Thanks, as James said, really appreciate all the technical presenters who indicated that they wanted to share what they've been working on with the forum. And our first presentation is entitled The Evaluation of the Fish-Heart Hydraulic Fishway for Upstream Passage of American Shad and River Herring. And our presenter is Steve Amaral, who's the principal fishery scientist for BioPassage Scientific Consulting. So with that, Steve, we can see your screen. And if you want to share your camera, certainly welcome it.
Yeah, I don't know if I can get my camera going. And I do have some videos, so it's probably better to save the bandwidth. But yeah, thanks for giving me the opportunity to present to the group here today. I'm going to talk about the Fish-Heart Hydraulic Fishway. I think many people on this call have heard about this new and innovative technology that's come out of Finland. Just a little background on me. The folks that do know me probably know me from my work at Alden Research Laboratory over the, I guess, last 30 years or so. I led a lot of lab and field evaluations of different fish passage technologies for diadromous fish. I did leave Alden last year and started my own consulting business, and that's what I'm doing now. And in full disclosure, I am contracted with Fish-Heart and representing them in the US and helping them identify sites where the technology may have application, and then facilitating some communication with the agencies and the dam owners as well. So get right into it. So this technology is interesting. It's barge mounted, It's a floating unit that can be placed in a tail race. And it can be one or more units depending on how many or how wide or big the site is, how many fish you need to pass. But it has two entrance conduits that you can see in the photo there that the fish enter into, and at least one is open to receive fish while the other may be transporting fish upstream. It's a steel frame. There are 6 different valves that control the direction of the flow. So obviously you have flow coming out when you're when it's open for fish to enter, and then when fish are being transported, the valves switch and the flow is reversed to carry fish up through a conduit and into the impoundment. It does have multi-camera systems for fish identification and data collection and species identification. There are 4 different attraction flow sources, so the 2 conduits themselves. And then up top of the unit, you can see this pipe here creates what is called a surface attraction, and then they have since installed a smaller pipe between the 2 entrance conduits to create a kind of a jetted attraction flow closer to the entryways. There are 4 different model designs that range in length from 21 to 27 feet, and they can be adjusted depth-wise depending on the site and how deep or shallow the water is and where the species are located. This is kind of a back of the envelope calculation, but it's possible you may be able to pass 70,000 or 100,000 fish per day. It'll be somewhat dependent on how many fish enter the unit and are transported at the same time, but it is typically a cycle of about 1 to 2 minutes from the time the valves close and the flow is switched and the fish are delivered to the impoundment. And with the 2 units operating in tandem, it's almost, sort of near continuous passage. This is a satellite unit. They call it the satellite heart. So again, if you needed more than 1 unit, this could be tied into the existing one at a different location below the dam or in the tail race. It uses the same technology as the fish heart. It could also be used at projects by itself if there are less fish that need to be transported or they're smaller. Again, it works as an additional entryway, and it can be integrated also within a conventional fishway entrance that might be performing poorly. So if you have fish that have trouble negotiating, say, a fish ladder, you could put this in the entrance or near the entrance to transport fish up. This is a video of an example installation in Finland. In this particular case, the unit has the entrance conduits facing upstream. Fish at the site generally approach the turbines and then recirculate in the eddy and then move back downstream, and that's where they're intercepted. You can see the surface attraction flow there. That's one of the things I think is kind of neat about it. It could be very beneficial for some species, perhaps not for others, but it gives you more options to pull fish towards the entryways. And at this particular project, you can see it, first year of operation, it passed over 13,000 fish, and then the next year, 19,000. These were probably a mix of salmon, sea trout, lamprey, and then some resident fish species. So this is, again, the schematic of the unit. You can see it floating here. The entryways are pointed upstream. The fish delivery pipe would be this one here. So number 3, this is a siphon, number 4, that brings water down to the system, and there is a helper pump. The helper pump is used to increase the velocity when the fish are being transported up to about 3 meters per second or 10 feet per second. That way there's less potential for the fish to fight the flow, and they can be carried pretty swiftly upstream. Just a couple of images to show the process. So here we have the 2 conduits. Fish enter. You can see the flow direction with the blue arrows moving this way. So it's, in this case, it's being pumped out of the tail race into this pipe and out fish enter. They are cataloged, identified, measured for length by the optical system and AI system. Once the fish are in and the system is triggered, it automatically operates on its own, or could be operated manually if needed. But once the fish are in there, it starts the passage sequence. The valves will switch, and then the flow direction comes here, and this is closed at the entrance. Any fish in the pipe are then carried upstream in that direction. And this again shows from a different viewpoint. Fish would be in this conduit following that flow up after the valve is closed and into the impoundment. And this would be the flow from the impoundment that feeds into the system. You can operate the system either with that siphon or pumping, depending on the site and how you want to configure it. The attraction flows typically are done with the pumping system and the tail race attached to the barge, and then the transport of fish with the siphon and the helper pump. A couple of photos of the installation in Finland. So you can see the system here below the dam. You can see there are conduits that would take the fish up and over the dam. In this case, they also have set up a collection tank, so they could divert fish up into here and then into the sorting facility if they needed to trap any fish. This is the AI system, and it shows an operator at it, but again, this operates 24/7 on its own and can be controlled remotely either from a computer or from a cell phone. So the FishHeart fisheye is the operating system, the monitoring system that records all the activity and initiates the passage sequence. It can identify the species after it's learned, what is what. It's linked to a FishHeart portal for real-time pictures and reports, and all species are identified with accurate counting and length measurements. It's capable of detecting and potentially removing invasive or undesirable species. The system is airtight. Obviously, it's underwater. And then the passage data, pictures, videos are, again, accessible remotely. This is just a picture of a large school of Baltic herring. It's pretty amazing, this number of fish. Keep in mind, this is only about a 16 to 18-inch diameter pipe, and that's the optical camera system where these images are from. And then once the passage starts, those fish would all be going upstream. All right, so moving on to the Santee Dam evaluation. So there's about 5 or 6 of these installed in Finland, and they are testing one right now in Australia. When we saw this technology, I first contacted the company back in the fall of 2021 and knew it was something that could have application here, but obviously would need to be vetted and fully researched for the different passage needs we have in the U.S. And so we teamed up with EPRI, and we applied for a grant from the Department of Energy for the evaluation of innovative fish passage technologies. EPRI was awarded the grant, and the site that was selected for testing was the Santee Dam, operated by Santee Cooper in South Carolina. Alden, which is now Verdantis, and I was part of Alden at the time, and they were subbing to EPRI to do the biological evaluation with support from Pacific Northwest National Laboratory for the acoustic tagging component of it. So we installed a full-scale system in the tailwater of the Santee Dam. You can see a picture of it on the right. It was configured to pass fish upstream into a collection tank about halfway between the tailwater and impoundment. So we could have gone all the way to the impoundment, but we did want to kind of intercept the fish and be able to handle them, look at injury, and hold them for delayed mortality. And then also, it was a good way to validate the AI video system. The system did operate 24/7, other than a 1-week period when they had high spill at the dam, and the system was removed in about 4 hours. And then when the spills receded, it was installed again in about a day. All fish that pass through the fish heart were recorded by the AI system, and they were enumerated from the collection and tank. And we were focusing on American shad for this evaluation. So all of the shad were assessed for injury and held for 24 hours. And you'll see in a sec, we did tag a number of them with pit tags and acoustic telemetry tags. Just a little bit about the location. So in South Carolina, you can see it here a little northwest of Charleston. It's part of a 2-reservoir system of the Santee and Cooper rivers, and the dam is the Santee Dam, which is at the outlet of Lake Marion into the Santee River. And there is a small powerhouse here with 1 unit and about 600 CFS flow through it. So the layout of the test, we have the fish heart installed right below the powerhouse with the conduit for fish passage up and into the collection tank at a parking lot, probably about 30 feet above the tailwater. We had several holding tanks for keeping the shad after they were collected from the tank. You can see the system deployed on the right in 2 photos, and you can see the surface attraction flow coming out. And this is the conduit that carried the fish upstream. This is only about 12 inches in diameter. Normally, we'd probably go a little bigger than this, but this was the pipe we had available for the budget that we had for testing. And at least for this application, it did the trick. Just a little bit on the collection. So here's the tank the fish discharged into. It's about 2 to 3 CFS coming out of the fish transport pipe. Pretty gentle flow and entry into the tank. We had isolation screen at the downstream end where there was an outlet for discharging the flow and lowering it, and then having somebody go in and pull the fish out. We did leave fish in here up to 6 to 8 hours, depending on when the passage events were occurring, and everything seemed pretty healthy and okay, even the shad. The only main issue we had there was some very large catfish eating smaller fish like herring. For the tagging, we electrofished immediately downstream of the powerhouse and the fish heart. For shad, they each about 400 received pit tags, and 100 of those received acoustic telemetry tags. You can see the hydrophone setup in the tail race just downstream of the fish heart. So we had 6 hydrophones that we could detect tag fish moving around downstream, and then 1 up above. These are wing nets that they installed to help guide fish to the entryway of the fish heart. All right, so moving on to the passage numbers. These are the 16 species that used the system while it was operating for about 3 weeks. Over 4,000 fish were passed through it. Of note, the American shad and blueback herring, which are the primary target species at this site, we had just under 700 herring pass through the system and almost 300 American shad. We look at the range of sizes in fish that were passed. We had fish as small as threadfin shad that were just over 3 inches in length, and then catfish that were upwards of 4 feet, or in this case, long-nosed gar, but also some catfish that were almost 4 feet in length. So really wide variety. And you can see some photos from the fish going through. American shad, gizzard shad, and a very large blue catfish. This is a video. It's kind of a bunch of clips put together just so you can see the fish that we did collect and go through. That was an American shad, and we have a herring here, a couple of herrings. So this would be basically when the flow, I think, was stopped and they were getting ready to reverse it and then send the fish upstream. Another American shad and a herring. And there's a big catfish. This window is about 4 feet long, so that catfish pretty much took up the whole length and then not most of the diameter of the pipe. There's a striped bass crappie, some herring swimming around, one of the long-nosed gar that we had go through. And we even had a few elvers, not many, but there were a couple. All right, a summary for the technology and the testing. Fish heart is an accepted technology for passing fish upstream at hydropower dams in Finland. The primary focus there is salmon and trout. They do pass a fair number of sea lamprey as well, and they also get a lot of resident fish species. The AI system provides real-time passage counts by species, and it measures lengths. Summaries of passage metrics are generated from the log data, and they can be accessed in real time, either from a computer or from a mobile phone. Very little or no loss of generation flow for attraction and passage compared to conventional systems. We believe internal efficiency is better than it would be for fish lifts or ladders, and there is no injury or mortality associated that we detected in the testing at Santee through any part of the system. Similar to other fishway technologies, the key to successful passage with the fish heart at most sites will be effective sighting and the appropriate attraction and entrance flow conditions. Obviously, a benefit of the system is it is mobile, so you can move it around to try to find the best location to intercept the fish and attract them to the entrances. I didn't mention it here, but before we did go to the field, Fish Heart contracted Alden to do a laboratory study in one of their fish testing flumes. A full-scale system was installed in the flume, and that's the middle picture on the right. And we got alewife during their upstream migration from a nearby fish lift, and we were able to determine that the alewife would enter the fish heart both alone and in groups under a variety of operating conditions. So elimination of the entryways and different attraction flows, that type of thing. And then, of course, the study that we just completed for the Department of Energy. And, you know, for 1 year of effort at the site, we were very happy with the results, both in that it is truly a multi-species fishway, but it did show it was capable of passing the target species, and that, you know, there may be some tweaking to do if this were considered for the site moving forward. There would be some additional optimization that probably would occur over another year or two of testing. But we think it certainly has the potential for passing shad and herring, not only at the Santee Dam, but possibly at other sites. And I will mention that it will be tested again at a hydro project in Connecticut this spring. And again, that's from American Shad. So it'll be good to get a second site under the belt and some additional data for shad passage. And I believe that is all I have. So I guess if I have time, I could take some questions.
Yeah, thanks so much, Steve. Very interesting technology. Really appreciate you coming out today. We have a couple of questions in the Q&A box, and I guess obviously folks are, you know, able to raise their hands and ask their questions directly. I can read them out, or if you want to raise your hand, we can let you ask directly. But I'll go ahead and start with the first question that came in, see if folks want to raise hands here. The question was, is the AI system able to accurately count and identify fish passing in large schools? And I guess I'll maybe extend that. Is there any sort of density at which the ability to identify individual fish is hampered that you guys detected in any of your testing?
Yeah, I would, for the Santee test, I don't think they ever had a large enough number of fish that it might have been a little difficult for the AI system. Certainly, like that school of Baltic herring you saw in the video, that could be challenging. So if you were to see big schools like that, you know, there would have to be some type of validation maybe at some point to try to figure out how accurate it is when it gets above a certain number of fish. for a certain density of fish in the pipe.
Okay. The next question we had was from Alan Weaver, who asked, how much does it cost to build, install, and operate?
So right now, they have a 3-year program that they work with the project owners on, that they, typically it starts out as a lease, and over that 3-year period, if it were to go 3 years, it would be about 2.4 million in capital costs. If it, for whatever reason, didn't work well enough, and it was determined within the first year or two, you would only pay for that first year or two. It is, the costs are heavier up front than they are at the back end of that 3-year period. The annual O&M is probably on the order of $50,000 to $100,000. Typically, they would work with the owner and customize a service program where they could do everything from installing it and removing it each year, and then storing it off site, and then doing a complete cleaning and maintenance of it, so that when it went back in the following year, it's basically going back in as new. Certainly, if an owner has the ability to store or wants to do the removal or installation, then it would be on the lower end of that annual cost.
Okay, great. And obviously, for folks who ask questions, if you've got any follow-ups, feel free to raise your hand. I'll do the last one in the Q&A box here, and then Wes Eakin will get to your raised hand after that. So Brian Sikowski asked if you had any information pertaining to fish going in and out of the pipe. And then there's a couple of follow-ups there. I'll go ahead and read the whole thing, and then we can break it down piece by piece. He also asked, were the wing nets applied during the entirety of the study? And do you think the results would have differed without those wing nets? And then finally, he noted it may be difficult to maintain those nets in most tail races in the Northeast. So yeah, so do you have any information about fish going in and out of the pipe? And then do you want to talk about the wing nets a little bit more?
Sure, yeah, so we certainly saw that in the laboratory study with the herring, and I'm assuming that it probably did occur potentially with the Santee Dam testing, but once fish are in the pipe, it will initiate the sequence for the passage, and again, it just continues to do it 24/7. The gate or the valve at the downstream end does close slowly. It's certainly possible that fish could move in and out before that valve is shut completely, and the fish do have to move in a certain distance to the pipe to activate and trigger the passage system. So that's something that hopefully we can look at the more these are applied and tested, and see what's going on there. As far as the wing nets, I think their feeling is some type of guidance probably will be beneficial at more sites. I think there was potential for fish to move past the system at Santee Dam. They always have a minimum amount of spill coming from the dam, in addition to the turbine flow, and then whatever was coming out of the fish heart itself. I think most of the fish, when the turbine is operating, are attracted to the powerhouse and go in that direction. But they do understand potential difficulties in some tail races with turbine discharge and the turbulence and velocities, and they take all that into consideration in the sighting of the fish heart, and then any kind of how they design and configure any type of guidance, which could be a net or it could be some type of solid mesh panel. They've had some talks with Pacific Netting who make the guidance booms, and they see this as an area they have to continue to develop in order to make sure that at any site they potentially could put this in and have an ability to guide fish to the entrance.
Okay, thanks. The next question was from Wes. I believe you're unmuted. Go ahead.
Great. Can you hear me?
Yes.
Awesome, thanks. So it's kind of in the same vein, and sorry if I missed it earlier, but I'm just curious if you had any upstream passage rates from your tagged fish.
Yeah, we don't have the data for that yet. I will say the number was relatively low of the pit tag fish. But we don't want to draw any conclusions on it yet until we've fully processed and evaluated the acoustic tag data, just to get an idea of what kind of percentages of fallback we had and how close, the fish were released within sight of the fish heart. You could see where we were collecting them. They were brought on the boat, tagged and released. So we do want to see how, what their behavior patterns were in the area downstream of the fish heart and as they approached it. The other aspect of that was, the predation issue we had with the catfish, and that, we passed a lot of catfish, and these fish could certainly be up and at the entrances of the fish heart and being a deterrent. So that's again something that we want to look at a little more closely and might have to be considered at some sites where like Santee, where predators could be a major issue.
Okay, that actually dovetails in nicely to one of the questions in the Q&A box from Maria. I wanted to talk a little bit more about if there's any thoughts, and maybe you covered this already, as to whether fish heart could have the potential to decrease the threat of predation at that pinch point, where fish may congregate below passage facilities. I think maybe you touched on that. I don't know if you want to expand on that anymore.
Yeah, the only other thing I'll say is that I didn't talk about it, but they, in addition to the wing nets, they have kind of a retainment system that they attach to the downstream end of the fish heart. And it's almost like a fight type design. And again, they've been working on optimization of this, particularly, they've developed it originally for salmon and trout in Finland, but now they're thinking about how it needs to be designed for herring and shad based on what they saw both in the lab and at Santee. But it is an opportunity to potentially funnel the fish, particularly the ones you're targeting, get them in an area at the entrance conduits, but then at the same time maybe preventing predators from getting there. It's still, this is at this site, Santee, obviously there are a ton of flathead catfish and blue catfish, and this would be an issue with any fishway system there at the entrance that these fish are going to congregate. We see that at a lot of fish ladders and fish lifts, whether it's catfish, striped bass, or something else. It's certainly, at each site you're going to have to think about that, what the potential is for it, and then how you potentially mitigate it with the way you design and operate the system.
All right, thanks. And then the last question we had in the Q&A box was about the pumping intake system and whether there was some sort of screening in that intake in the impoundment, or and whether or not that there were screening requirements that had to have been met, or there were any concerns around implementing screens at that intake in the impoundment.
Yeah, I think they probably do have something on it, and if not, I'm sure something could be added to it. Again, it's not a lot of flow, it's only a couple of CFS. But if there was a concern, I guess, for entrainment of any type of fish through that, yeah, they could put some kind of screening on it. I think they do have on their tail race pumps, they do have something to help with debris and also to keep fish from going through the pump when they're withdrawing for their attraction flow.
Thanks. Yeah, I really appreciate you coming today, Steve, and presenting about this technology, and look forward to learning more as the results continue to roll in. So we are right on time here, so we'll go ahead and switch over to the next presentation. We kind of set them up to be a little bit of south to north, so moving up the coast to Long Island. We have Dr. Peter Daniel from Hofstra, who's presenting about the importance of monitoring fish passage on the Peconic on Long Island there. So,
okay, so Hi, I'm Peter Daniel, and this is a talk that that's based on my graduate student Carolyn Apple, her thesis work, and she presented this at the Northeast Division American Fisheries Society meeting that was held last fall. So this will be very, very similar to that talk. We are looking at fish passages that are in a river called Peconic River on Long Island. And essentially, we have two back-to-back fish passages, one of which is a technical fishway and one of which is a nature-like fishway. And if you look across Long Island, we've added a lot of fishways over the past 16, 17 years. And they vary considerably in the type. Most of them are technical fishways. I think this shows like 16 fishways on this map. Most of them are technical fishways. There's 3 of them that are nature-like fishways. Not very many of them are being monitored. So all the ones that are labeled red here have either had spot monitoring or no real monitoring to see how successful they are. There are 4 green symbols on the map, and those are ones that have had some relatively consistent technical monitoring, typically consisting of either underwater video monitoring or which may or may not be coupled with some pit tag work. So the area that we're going to be looking at is right here. On the Peconic River. Peconic River goes, unlike most of these other rivers here, which are north-south oriented, this one goes east-west. And it's for Long Island, it's a fairly decent sized river, and has a number of dams on it. And 2 of those have well, there's several fishways that have been put in place, but 2 of these actually allow access to the estuary, so fish can move up these, can reach the fishway and move upstream if they can make it. So, as I mentioned, this is a fairly large river, and there are a massive 24 kilometers long. There are 6 barriers on the river, and several of them now have fishways. You can see in this map, there's 4 fishways around those barriers. There's still 2 barriers remaining, one of which actually blocks the access to the 2 upstream fishways. So basically, the only real habitat access is at the lower end of the Peconic River up to the Upper Mills Dam, and also on a tributary of the Peconic River called Little River that runs to the Woodhull Dam. The first fishway was built in 2010, and it's a nature-like fishway, which you can see in the right on the right-hand side. It restored 25 acres of spawning habitat. It's in a park called Grangeville Park, which is what I'll be referring to it as. And then the next one, which is up Little River, where Woodhull Dam is the Byron Young Fish Passage, which was installed in 2022, or at least the first season. It was, well, actually, it hadn't quite been finished in 2022. The first season it was actually usable was in 2023. And so this is a technical fishway, which it is hoped will restore 95 acres of spawning habitat upstream of it. So what we're doing in the Peconic River is monitoring fish passage in a sizable spawning population. This is probably the 2nd largest spawning population on Long Island. And of course, we want to know how efficient the fishways are that are installed in the Peconic and its tributaries. Do they attract alewife? And if they do, are they passable? And we're also interested in how fish passage compares between a technical fishway and a nature-like fishway, because we have the 2 essentially in series servicing the same spawning population. So looking at the monitoring going on at Grangeville, we've been monitoring there since 2020, using both a camera, underwater camera, which you can see in the lower right-hand corner, and also some antennas we put up to detect pit-tagged fish. So the pit-tagged fish have been used. What we found with pit tagging was that there are a lot of fish that are basically doing a lot of multi-passage. They're going upstream into freshwater, and then during the spawning season, they're returning to the estuary. And maybe they'll do this only once, but there's a significant number of them who'll do it 2 times or 3 times. And in fact, if we use the proportions of multi-passage, we actually end up can use that to adjust our visual counts to get a more accurate idea of what the actual passage is, the actual number of fish are compared to the number of passes through the fishway. And it turns out it's about a 70% reduction in visual counts. We can also determine what percentage of fish are returning annually, how long fish are staying in the area during the spawning season, and also get some measurement of passage efficiency. Based on the video camera and monitoring adjusted for repeat passage, we've estimated spawning runs of about 6,000 to 24,000 in prior years of 2020 through 2023. So the other site, the Woodhull study site, is a pool and weir passage, and here you've got also a camera we've added, and we've been monitoring this since 2023. The first year the camera didn't work very well, and so we don't really have a lot of good video of that, although this past year, 2024, we've had a lot more success with the camera. We also have pit tag antennas set up at this site too that can allow us to measure attraction, passage efficiency, and also we're looking at, which will be much of what I'll be talking about actually today, is the pattern of passage attempts. So in 2023, we had tagged and released 296 fish right below the Woodhull Dam. This is a place, the pool right below the dam is a place that a lot of fish congregate. So we can just put in cast nets, grab the fish, tag them, and put them back where we got them from. Last year, we tagged an additional 400. Those are the ones that are returning this year, along with probably some ones from 2023. And this, what I'm going to talk about today, is focused entirely on the fish that were tagged in 2023 and returned the 2024 spawning season. This is our antenna arrangement at the Nature Lake Fishway in Grangeville. We have an upstream antenna and a downstream antenna, so ostensibly we should be able to determine passage efficiency there. And then at Woodhull, we have a downstream antenna at the entrance to the fishway, and there's a large entrance pool at the bottom, and then maybe about 5 meters in, maybe not even quite that far, but around 3 to 5 meters in, there is the pull and weir ladder starts. This is at the top. There's an antenna here, and you can see the fish ladder in the middle picture. So at Woodhull, we can actually, because we have antennas downstream at Grangeville that are detecting the fish that would eventually get to Woodhull, we can actually measure attraction at Woodhull. Since we know how many are going upstream, and then we can basically assume that the fish that are detected downstream at the downstream antenna are in the vicinity of the antenna and then therefore dividing that from the ones that made it upstream from Grangeable, we can get attraction. So this is what we've gotten for return rates to the area for tagged fish. And you can see that in 2024, we actually had our highest return rates of 31%. So as low as 9% up to 31%. So this would be tagged and released the prior year. We also get returns from fish tagged 2 years before, and at least we've had one case where a fish was tagged 3 years before. So looking at passage efficiency, the efficiency at Grangeable is much higher than that at Woodhull. So you can see we generally are getting somewhere between 90 and 100% passage efficiency there. And at Woodhull, about 90 fish were detected above Grangeable, and of those around, I think it was 83 were detected later at Grangeable. So that's at Woodhull, sorry. So 90 were detected above Grangeable, and of those 92% were detected at Woodhull. And then of those, none of them made it upstream. So there was 0% efficiency, despite having most of them being at least detected at the downstream antenna. So in this case, we're calling passage efficiency. It didn't make it to the upstream antenna. And so this is what it looks like underwater in the pool, the entrance pool. The place that was last spring was just packed with alewife. So they're filling up the entrance. And if you look at on the right, this is looking up the pool and weir. And if you look carefully, you can see some fish that are falling back in the first pool, from the first pool. And you can even occasionally see some fish that even made it to the second pool above it. So they are trying. And this is the typical pattern of some examples of patterns of detection. We're looking at Grangeable downstream antenna, Grangeable upstream antenna, Woodhull downstream, and then Woodhull upstream for 4 different tags. And so you can see movement upstream from to the upstream antenna Grangeable, and then a few days later being detected at Woodhull. And then you have this series of detections that occurs after that before a fish might move back downstream and leave, like this fish did, and then return a few days later, go back upstream to Woodhull, and then a number of detections at Woodhull again, and then back downstream and apparently leaving the area. And you see a pattern like that throughout for the other 3 here. And the thing to notice here is that you can see that there's not all that many detections that occur at the Grangeable antenna. There's actually the appearance of a lot of detections at the Woodhull downstream antenna. And if you look at when we looked at the period between a sequence of detections, so what we call the interdetection interval, and looked at interdetection intervals for detections at Grangeable versus Woodhull, right? So this is how long between a tag being detected and then being detected again. And this is graphed according to the detection interval. So as you go along the x-axis, we're looking at the number of detections that are greater than that detection interval. So in other words, the number of detections that might be 2 hours or greater, or 10 hours or greater between two detections. And so Grangeable shows, and both Woodhull and Grangeable show a pretty steep cutoff to 1 hour, right? And then it levels off. And you notice that Grangeable detections level off at a much higher level in terms of the proportion of detections than Woodhull. So many of the detections at Grangeville are actually in the 2-hour or greater range, while most of the detections at Woodhull are the vast majority are less than 1 hour. And you can see this in the table showing that a lot of total detections at Woodhull, the average detections per tag is much higher at Woodhull, and the number of detections that are greater than one have the interdetection intervals at Woodhull that are greater than 1 hour are only 18% compared to 67% at Grangeville. So let's just look at one of those tags again. And so if we look at a period of detections between Grangeville upstream to the next time the fish is back down to the upstream antenna. So this series of detections right here, we have a series of detections, and then just focus in on one of these. So this is what we call, this would be detection duration and number during this sequence. Okay, how many detections were here and how many, how long they were detected here and the number. And so this is zooming in on that. And so this is that whole sequence, and you can see there's quite a few little detections here. And then if we magnify this here closer, you can see that just this little blob right here actually consists of four detections. So we call these, this is an interdetection interval right here. This one's less than an hour. And then this is an isolated detection, which is a detection which is isolated from the prior detection and the next detection by at least an hour. And then where you have a series of detections that are less than 1 hour apart, that is called a cluster. So this is a cluster right here. So this is 4 detections making up this cluster, and each one of these blobs right here then represents a separate cluster. So what we've found, and I'm going to just pass through this really quickly. What we found is that when you compare Woodhull to Grangeville, you don't see, in Woodhull, you see lots of these clusters of detections. You see a lot of detections that are very close together. And then there's a pause, and then you'll see another cluster. So I'm just going to pass right through this really quickly so I can get to some of the conclusions here. So the cluster duration at Woodhull is longer compared to Grangeville. There's many more clusters at Woodhull compared to Grangeville. The number of detections per cluster is much greater at Woodhull than it is Grangeville. And at Grangeville, there's a high number of isolated detections compared to Woodhull. In other words, you'll see one detection and then it'll be several hours before you see another detection there, or maybe several days. That's unusual at Woodhull. Most of the detections are at least have one neighbor that's a cluster. So our conclusions here are that AOI are at least at Woodhull are passing much more efficiently through the Nature-like fishway than the Pool and Weir fishway. Interestingly, we don't really have any evidence that the technical fishways on Long Island allow efficient passage. Most cases it really hasn't been measured, but where it has been measured, and there's been 2 other technical fishways where passage has been measured, and it hasn't been it doesn't look very successful. The Woodhull fishway is attractive. It's just that the fish are, and we can see the fish are attempting to pass, but they're just not making it up to the top of the ladder. This is probably very stressful for alewife, these constant attempts. And the subpar passage conditions may be indicated by by the low proportion of interdetections greater than 1 hour plus the frequent detection clusters. Now, we did, as I mentioned, we did have a camera there. This is the results of the camera monitoring at Woodhull, and there were fish detected that made it up. Obviously, none of these were the tagged fish from 2023. Oops. During that time period, we attempted to adjust flow. We added flow, we removed flow, we added boards, removed boards, but from both the exit and the entrance, and really didn't see any success. It doesn't seem to be any real correlation. There may be a little bit towards the end here, but I don't where boards were added, but nothing that stands out systematically. But regardless, we've estimated that about 1,000 alewives successfully passed, and we do have evidence that juveniles, they're responding because juveniles were observed last October at the upstream pool of the Fishway. And interestingly, this year, so far, we are getting fish going up the ladder. Now, it's not really high numbers, but it's a lot more than what we've seen. You can stand. Yesterday, I stood by the observation pool and we saw about 15 fish go through in about 45 minutes. So that may be there. I think there's been last year was very a lot of water flow because of some very drenching rains, and this year we're kind of in a drought phase where water flow isn't back up to normal. So maybe that's having an effect on it.
Thank you so much.
Sure.
Appreciate all the efforts to keep on top of pastures there on Long Island, and look forward to hearing more in the future. We're going to move up the coast now to Justin Hearn from SUNY ESF, who's going to talk about exploring migration histories through biomarker chemistry for blueback herring in the Hudson Mohawk.
Perfect. Okay, I've never switched back and forth before, so thank you for that tip. Again, Sego Seo Guego. My name is Justin Hearn. I'm a member of the St. Regis Mohawk tribe in northern New York. I am a graduate student at SUNY College of Environmental Science and Forestry in good old central New York, Syracuse, New York, under the advisement of Karin Limberg. I'm here to tell you about my awesome graduate research I'm doing, exploring the migration histories through biomarker chemistry for the highly migratory and cryptic blueback herring. Some of this might be a little repetitive. I know that this is probably one of several river herring talks about blueback herring you may have heard in the last, hour, so please bear with me. Blueback herring in New York State is one of 2 river herring species, the other being the alewife. Its distribution ranges from Cape Breton, Nova Scotia, all the way down to St. Johns River in Florida. In its classic anadromous lifestyle, or its textbook lifestyle that we know of, it spawned in freshwater tributaries where it rears from weeks to months in its natal environment. It then makes its first migration out to the marine coasts and environment for 3 to 5 years, where it matures. It'll then migrate back to its natal environment to make its first spawning event. These are ecologically vital species where they link from the planktonic realm of zooplankton to apex predators like bluefish and striped bass. Along the coast, we know that populations are relatively historically depleted, which has triggered a lot of management restrictions for commercial and recreational individuals. Hudson River, close to the Peconic Bay, but a little bit more north, is New York State's longest river, 507 kilometers. Its origin is Lake Tear in the Clouds in the Adirondack Mountains near Keene, New York, extends through the Hudson Valley and empties into the New York Harbor near the Battery in Manhattan. Its Mohican name, Mohicantuck, describes its semi-diurnal nature in the estuary portion where the waters are never still. It's also a very biodiverse hotspot where a minimum of 237 species have been recorded throughout the entirety of the river. The Mohawk River is the Hudson River's largest tributary. Its Mohawk name describes its origin near the Tug Hill Plateau near Boonville, New York. It extends southwest through the Mohawk Valley and empties into the Hudson River near Cohoes, New York. As the main tributary, it accounts for 25% of the Hudson River watershed's total drainage area. Cohoes Falls is a 75 to 90 foot natural falls system, creates an impassable barrier. I think the historical documents have identified only the American eel as making the trip up the falls or being able to pass the barrier. So 2 diversified river systems. In the 19th century, the Erie Canal was finished, which created an aquatic highway from Buffalo to Albany and down to New York. To basically get around the Cohoes Falls, the Waterford Flight of Locks was a series of several locks in canal segments, created a seamless passageway from one to the other. In the 20th century, around 1934, the first account of blueback herring utilizing the Erie Canal to get into the Mohawk River was recorded, with research later in that century identifying deviations in their life history and their behavior. More recently, the New York State Department of Environmental Conservation has expressed interest in identifying the significance of the Mohawk River, what its role is, and what it essentially can do for or with the blueback herring population in New York State, which leads me to my graduate research. I don't really have a lot of time to go into both objectives, so I'm just going to stick with objective 1. So the first portion of my thesis, I wanted to start by determining natal provenance for blueback herring. So is this a Mohawk-born individual or Hudson-born individual? And then from there, I wanted to see if I could utilize different analytes from eye lenses or otoliths that can aid in provenance elucidation. So determining which is Mohawk, which is Hudson, or something else. Samples were taken in 2020, 2021, and 2022 by Region 3's Stanford Fisheries Unit under the direction of Scott Wells, above, near, and below the confluence of the 2 rivers. Boat electroshocking, one of my favorite field sampling methods. Adults were harvested, biologic data was taken, otoliths and eye lenses were both extracted, embedded in epoxy. After curing, they were both polished until the cores were exposed, and then prepared for laser ablation, inductively coupled plasma mass spectrometry in-house at SUNY ESF's Analytical and Technical Services under the direction of Deb Driscoll. If you're not familiar with LA-ICP-MS, essentially you can see me in the middle drawing a transect across an otolith sample. You can see some otoliths prepped and ready on the LA slide to the right. Utilizes the laser ablation where it blows through the material, it vaporizes it, and then the mass spectrometry quantifies the different analytes and then their ratio levels in regard to calcium. So it's really exciting methodology. Also, you can see an eye lens here where the core was exposed. That was really exciting. I've never polished eye lenses. Otoliths were really beautiful and also very fragile. So I cracked a lot of them, and Carton was not too happy about that. First things first, we needed to start with determining our provenance estimations. This was possible in the Hudson and Mohawk because they differ geologically. The Mohawk is strontium enriched, Hudson is strontium depleted. When we look at the strontium to calcium ratios in textbook examples like L3 and N3, we can see that L3 is Hudson born, it's strontium depleted, and we see that it ranged from a 1.0 to 1.5 in its readings. If we look at the Mohawk signature, it is elevated above 1.5 and it ranged to 2.5 to 2.75 in this study. Interesting enough for the Mohawk individuals, they're elevated. So when they enter the depleted Hudson River, we can see that there is an abrupt depletion or jump down into the Hudson River. It's very characteristic. And then for both, we can also determine when they emigrated out to the marine environment, which is shown by the gradual increase in the strontium to calcium readings. Anything above a 3.0 was determined to be the marine environment. So Barium to calcium readings were also utilized to validate freshwater or saltwater. The relationship with barium, it is free in the freshwater and it is bound in the saltwater generally. So we went through and we were able to determine our natal provenance. However, we did have several individuals that didn't follow this predictable pattern. It was very confusing. Karin and I were scratching our heads for several weeks and we didn't really know what to do. You know, we went through multiple times. We had multiple iterations of trying to determine provenance. These individuals did not follow the typical 1.0 to 1.5 threshold for Hudson or the 1.5 to 2.5. You know, if we did determine that, oh, maybe they were Mohawk, they didn't essentially have the typical jump into the freshwater portion, or it wasn't signified. We looked at the barium, it was very squirrely, wasn't really able to determine if it was truly freshwater or saltwater. After going through different literature with Karin and then more discussions, we did conclude that these were individuals that were spawned in the estuarine main stem. So going further, I want to be clear that spawned in the estuarine main stem is anything that was below the salt front and then down to the more brackish or the Battery in Manhattan. So that's what we're calling the estuarine main stem. When we talk about the Hudson River, we're talking about the freshwater tributaries and the freshwater portions above the salt front. So I just want that to be clear. From there, 148 fish were collected. Only 64 of those were analyzed for this portion for both otoliths and eye lenses. A suite of 20 plus analytes for both otoliths and eye lenses were performed that ranged from metals and non-metals. In the first portion of my analysis, I wanted to determine if there were differences between analytes and all three natal provenance locations. So utilizing annual analyte data, analytes were tested. 9 analytes came back as showing statistical differences between one provenance to the other, or one location to another. Out of those 9, 6 were identified as having multiple differences between the Mohawk River, Hudson River, and estuarine main stem. You can see that I color-coded some boxes. Otolith strontium was an analyte that followed a normal distribution but unequal variances, so a Welch's ANOVA was performed. And then everything else was an unequal distribution, so a Kruskal-Wallis was performed. All analytes were then performed to the Steele-Duas post hoc test. Essentially, we could determine that there were differences between the Mohawk River, Hudson River, and estuarine main stem. However, this initial portion did not quantify any relationships that may be present in the aquatic environment or any interactions that may occur. So we needed to take it a step further. So this wasn't the end, unfortunately. A principal component analysis was then performed in phase 2. So all analytes that we utilized in our study were compiled into a test to determine which may be influential in determining natal provenance. So to start, 3 eigenvalues were determined as being the most influential. They accounted for about 50% of the overall variance in our data. Principal component 1 spoke to the most variance, and principal component 3 spoke to the least amount of variance. In this depiction that we see, the biggest takeaways are that principal component 1 was heavily influenced by eye lens metallic analytes. Principal component 2 was heavily influenced by metallic otolith analytes, and then principal component 3 was heavily influenced by the isotopes of mercury, which was 202 and 198, that were captured within the eye lenses. So anything in our PCA analysis that scored above a 0.5 loading coefficient, so moderately influential and above, was then selected and then chosen for the next portion. Part 3 of my analyses was to perform a discriminant function analysis. So anything that scored 0.5 that was significant was then plugged in. We essentially asked a model to help quantify natal provenance based on our original provenance estimations, and then to come up with whatever guesses they could do with the analytes that were given. Essentially, what we found is that we had 95% confidence that the model was able to identify natal provenance for all but 2 individuals. So there was a low misclassification rate. When we look at the graphic on the left, we can see that there is differentiation between all natal provenance groups. And then the vectors that are shown are the different analytes. The larger the vector, the more influential they are on the different natal provenance. For instance, the Mohawk River was very influenced by otolith strontium and lens manganese and lens magnesium. The Hudson was more influenced by otolith barium, and then the estuarine natal provenance individuals were very influenced by lens rubidium and then lens 198 of mercury. We look to the right, we have our standardized scoring coefficients for both canonical 1 and canonical 2. We know that we utilize strontium and barium. Those are the bread and butter for utilizing LAIS-PMS for determining natal provenance. The analytes that scored high on our coefficients: lens magnesium, lens manganese, lens rubidium, 198 mercury in the lens, and then otolith phosphorus were the most significant and influential analytes that we were able to determine could help aid in provenance elucidation for this study. So that's exciting. I would have had no idea that a lot of lens analytes could be more influential than any otolith analytes. That is exciting because eye lenses are they're just a different structure. It's something that has not garnered a lot of research right now, but it is very budding in the field, and it just shows a lot of prominence for helping to determine natal provenance. Looking more at some of our results, 64 were analyzed, 2 were misclassified, so our misclassification rate was low, like 3%. That's really awesome for me. Our entropy R-squared is the ability for the model to correctly classify natal provenance based on our original estimates, was a 0.8, so that's pretty high. And then the -2 log likelihood essentially determines model fit. Before my PCA analysis, I was running just random analytes in this, and I had anything from a -2 log result as like 480, 120, 260, doing it the right way with a PCA, and then at DFA, I was able to get a 23. That's awesome. That's great model fit. If we look at the confusion matrix on the right, this is telling you what was correctly classified, and then anything outside of the oblique top left to bottom right ladder was misclassified. So we correctly classified all Hudson River. That's great. Mohawk River, only one was misclassified, so I originally classified it as Mohawk, but it was technically estuary, and then vice versa. I had correctly classified 7 estuary, and then the one oddball, I incorrectly said it was Mohawk, but it was actually estuary. Below are pictured the individuals that were misclassified. Again, really hairy, very unclear from their strontium to calcium signature. Their barium to calcium is in red. I should have changed that to orange so it was on brand. However, just very unclear. So unfortunate, but it was a low classification rate. So main takeaways: Hudson and Mohawk provenance elucidation, we were able to do that based on the strontium and barium signatures. Also, it was exciting that we were able to identify estuarine origin or estuarine spawned individuals, some otolith and eye lens chemistry to help tease out additional analytes, so lens manganese, rubidium, the isotope 198 mercury in lenses, and then lens magnesium and otolith phosphorus were shown as very promising in helping to determine natal provenance in this study. In the future, I would like to go through and not only analyze the rest of the analytes or the rest of the otoliths that are sitting and waiting, but also repeat this study with taking water chemistry to help ground truth the strontium, barium, and also other analytes that may be in the environment. I would also like to have more sample locations that would be in the estuarine portions, in the mid-Hudson area, and then potentially more in the Hudson or more in the Mohawk that are not just in the lower Mohawk, but closer to like Oneida Lake. We know that individuals have gotten all the way up into Lake Ontario, so it'd be very interesting to see if different signatures through eye lenses and otoliths are incorporated into that. And then finish the second phase of my research, which would be utilizing BAT calculations to identify egress lengths and see if there are variations in timing to sea, their first emigration to sea, and to determine if there are just different lifestyle characteristics for those individuals. A lot of people have helped made this journey possible. Region 4 under the direction of Scott Wells, DEC's Region 3 under the direction of Wes Aiken and the Hudson River Fisheries Unit, Karin, my advisor, Robin Kimmer at SUNY ESF, Analytical and Technical Services, Deb Driscoll, and then the Lindbergh Lab cohort. And that's it, and I'll take any questions. I have some cool photos of Karin and myself and my work in the Hudson River as a fish technician. And thank you so much.
Great presentation, Justin. A ton of work obviously went into this, and this is only half of your master's thesis, so very impressive.
I know. I can't imagine that I still have more to go.
Hang in there. Let's see. If we've got questions, raise your hand, enter them into the questions box. Give it a minute to see what filters in there. But yeah, really appreciate it, and hope you'll come back and and give us an update when you have worked through the rest of your thesis.
Absolutely. Yeah, I'm excited to see what part 2 has in store. I know that Karin and I are waited with bated breath. So,
right. Great. Thanks so much.
Thank you.
Question box.
All right, moving further north to the Connecticut River, we have Jacqueline Stevens from UMass, who's going to present on the quality of past spawning estimations for blueback herring and population assessments. So look, we can see your screen. If you want to turn on your camera, great. And I'll just turn it over to you to take it away. Thank you.
Perfect. So hi everyone, my name is Jackie Stevens and I am a Pathways intern with the U.S. Fish and Wildlife Service, as well as a recently graduated master's student from the University of Massachusetts Amherst, where I was in Adrian Jordan and Allison Roy's lab. And today I'm going to be talking about part of my master's research, which was evaluating the quality of past spawning estimations for Connecticut River blueback herring population assessments. So I wanted to start with just a brief dive into the review of river herring management, and I wanted to start with a plot that we're probably all pretty familiar with. So we have year on our x-axis, and we have the number of fish that were landed, river herring number by millions for both our commercial, our foreign fleets, our recreational, and bycatch. So this plot does a pretty good job of seeing that really strong peak in the late 1960s, and then that unfortunate decline following it. And while the Magnuson-Stevens Act was probably the first to positively impact our river herring populations, the first direct management was conducted by the Atlantic States Marine Fishery Commission with their fishery management plan for both American shad and river herring. And since then, there have been amendments to that fishery management plan. Specifically, in 2009, we have our Amendment 2, which required states to provide and get approved sustainable fishery management plan, as well as some benchmark stock assessments and updates that have been conducted with our increase in long-term monitoring programs, both in fishery independent and dependent programs. And a common conclusion has been that river herring populations have been depleted on a coastwide basis in near historic lows, and these conclusions have been based on the data that has been provided. So a lot of analyses have been kind of data limited with what we had for both time series and the variation in the data being collected and the gear being used. But for the data where we can incorporate in some demographic data, such as age and our spawning history, we have been able to use some more complicated analyses and look at some trend analysis, as well as get some estimates of growth and mortality, as well as using spawning history specifically for looking at metrics of minimum repeat spawners, because as Idiroparia species in the Northeast, that being a really strong component for assessing the health of our populations. Unfortunately, the age and spawning mark have not been validated for river herring specifically, so there has been some concerns expressed about using this data in these stock assessments. And that has resulted in these biannual quality assessment and quality control fish aging workshops that began in 2014 and were concluded in 2018, with results not really showing a lot of benefit in conducting them, as well as this main conclusion that states should be implementing their own kind of control measures for the demographic data that they're collecting. So it came down to the organization itself, and there haven't really been any standardized on a regional level for both age and spawning estimation data being used. So now just briefly on where we're actually collecting this from. So you may be familiar that demographic data is coming from our calcified structures. So similar to growth rings on a trees, we can get that from otoliths, our scales, porculums, and fish spines. And specifically for blueback herring, we usually look at otoliths for our age and scales for age, and they also have our spawning history. So as I mentioned before, this is a mark on the scale that we can interpret as past history of that fish returning to fresh water to spawn. So it's this degradation of the scale. The fish is stressed out, returning, migrating upriver into this freshwater system that's ion deficient, and they're kind of absorbing their scale, and it leaves this degraded mark on the scales that we can quantify and assess how many times that specific fish has returned. And scales are great too because they're a non-lethal method of getting both age and spawning information. And just some examples we have here. So this is an example of a scale from a virgin fish. When it was collected, it was returning for the first time. We can see clean annuli going around the scale, no really jagged marks anywhere. But now moving on to this next one, we do have a spawning mark identified there in the blue arrow. Returning when it was collected for its second time. It had spawned once before, it was returning. And now another one, we have 2 spawning marks identified on this scale, followed by 3 here. And you can see that third one. I don't know how well you can see it on the screen, but it's easier when you have the microphage. But then we also see scales like this, and it's a mess, and no matter what you do to try to manipulate the image, you don't always get this clear idea of what you're looking at. And when we have these long-term monitoring programs, there's usually a lot of turnover for the employees that we're having on our crews. So it's a really great experience for early career scientists in fishery biology. But we want to make sure that the data we're collecting for these long-term monitoring programs are consistent and accurate, and that each reader every year is getting the same training and is going to say the same thing for that scale. So that brings us specifically to the U.S. Fish and Wildlife Adult River Herring Stock Assessment that was conducted in the Lower Connecticut River at 5 tributaries along the main stem. And it was established in 2013 and is still currently running up until now. So this is our 10-year data set that we're using. And Ken Sprinkle, who runs this project, has expressed concerns in the past, again, with this overturn of our employees, really wanting to assess our confidence in the spawning estimations that we've collected over the years. So our objectives were to assess the presence of systematic bias between readers. So that's non-random. Was one reader maybe interpreting an annulus as a spawning mark when it was not a spawning mark, and that led to them commonly overestimating spawning history compared to the other reader. We're looking at levels of precision. Again, since age and spawning mark hasn't been validated, we can't call it accuracy because we don't have those true known ages or spawning events. So we're looking at precision. So this is basically the reproducibility between the spawning estimations between readers. And then we also wanted to conclude with developing this training manual for future readers specifically for this survey. So our methods for doing this, we identified the Evans and Honig diagonal pooling test of symmetry, and this is just the equation that goes along with it. And this is an example from 2018 of a estimation frequency table. So we have reader 1 going down in the first going across, and reader 2 going down. And you can see that following the color scheme, it will take the values within those, subtract, add, and complete that calculation and give us a chi-squared as well as a p-value. We'll be using an alpha of 0.05 value to indicate whether or not bias was detected between the two readers. For our index of precision, we're using the Chang's coefficient of variation. And the main takeaway for this is that lower CV values are higher precision. And there have been 3 kind of proposed thresholds that have been thrown out there for acceptable precision, and they can come down to being study specific and dependent on the species that you're working with more longer lived species, maybe using those higher thresholds with the higher chance of variability. And then for our third, just being the science-based best practices for scale preparation and interpretation. So this was reviewing what we currently had at Fish and Wildlife, collaborating with neighboring state diadromous biologists, and then identifying prior scales to create both a training set as well as a test set for our future readers. So diving right into our results, so this is going to be a table of our years going across in that first row, again from 2013 to 2023, and we have N as our sample sizes with a minimum sample size of 362 and a max of 1,461 in 2019. In bringing in our bias detection, that's our chi-squared value, and focusing in on our p-value, we are looking for values below 0.05. So we have here that 70% of our years that we looked at annually had systematic bias detected. So that's non-random. One reader was often X off compared to the other. And then bringing in our CV value, CV values are known to be inflated when bias is detected. So when there's non-random bias, then we can have this increase in our CV values, which again, higher values of CV means lower precision, higher in precision. Sorry, if you get confused along the way, I might go bounce back and forth with those. But looking at our CV values, we can see that with that 10% threshold, we had 30% of years falling above that. And not all the years that had bias detection were actually able to fall under our 7% as well for our threshold. And another observation we can make from here is that starting in 2019, we did kind of see this increase in our precision between the two readers. But then we kind of wanted to dive a little bit deeper. This, again, the sample size is all of the age classes that were present within these sampling years. And we know that older fish can kind of lead to this primary source of reader disagreement. So we wanted to incorporate in how age class might be affecting this. So we did our recalculations, and this is just a visual of the results from that. So we have age class on our x-axis, and then we have our coefficient of variation on our y-axis. Again, lower values meaning higher precision, and I have highlighted the 5, 7, and 10 thresholds. For color, we have red being that bias was absent, it was not detected between the two readers. So they're good there. And then blue being that it was present, so there was non-random bias between those two readers. And then for our size of our dot, as well as X's indicating sample sizes. And we did have sample sizes below 25, primarily on our early end and our later end of our age structure. So looking at this, we did generally see that There was an increase in our CV values with older ages, as well as when looking at a specific age, that red dots were usually lower than blue dots, again, with that inflation of our CV values with bias being present. And then looking at this visualization, we also wanted to look at those specific older ages. There were a few occasions where they had really great precision, where there was probably a handful of fish and the readers got them all correct. So we have 0 for our CV. Both readers said everything correctly or the same. But we wanted to look at how those older age classes with those really high CV values might be impacting our calculation of annual precision and bias detection. So with bringing back in that table that we showed before, again, with our indicated years that had bias detected and our CV values, now our new row has the amount of fish that were removed from age classes that had less than 25 fish. We can see ranged from 2 to 47. And now we bring in our new CV value, and it shows the same years having those above 10% threshold for a CV, as well as the same years in our red box indicating that bias was detected. And looking at that bottom row, we can see the change in CV, and none of those changes were significant enough to bump a specific year down to a new threshold. So the main takeaway being that the presence of age classes with our less than 25 fish did not really overall impact our annual calculation of precision and bias detection. And our last results was we created this training manual and reference collection specifically for the U.S. Fish and Wildlife Survey, river herring in the Holy Scale. And the start of it, it explains where you're actually collecting the scales from, how to process and clean them. It goes over basic scale structure as well as mounting our scales. And then the results of implementing this into 2023 was that we had that highest annual precision in the time series, falling below our lowest threshold of 5, and it didn't have bias detected. So kind of the recommendations that come out of this report and this study overall for spawning estimations is really the importance of having uniform training, specifically within your survey itself. Having those in-house training manuals, if you do have those turnovers with the staff that are actually collecting the data, having reference collections, again, talking about that training and that test collection, having something for readers to see before they get into production aging or estimating, and then maybe revamping those regional workshops and having an open discussion about what we can think for thresholds. And again, discussion of precision thresholds, we saw that for the most part, we did have our annual values falling below our 10%. So that might be a good starting point that we can talk more about at a regional scale. And then thinking about the fact that we can't assess accuracy until we have these validation studies and what we can work on with mark and recapture, and thinking about how to get these true ages and true spawning events for the future. And I just wanted to also share some of the resources for Excel specifically. We had Sandy Sutherland from NOAA Fisheries has a bunch of templates for precision and bias, as well as if you're using R, there is Dr. Derek Ogle's packages that were really helpful in my analysis. So finally, the main takeaway being, if we want recovery, we need these best management decisions, and those come from our unbiased population estimates. And ultimately, those come from a really large quantity of quality data. And that starts with our proper collection, processing, and interpretation. So thank you all for listening. Thank you to my funding sources, Fish and Wildlife Service, UMass, and USGS Co-op Unit. And a special thanks to Ken Sprinkle, Scott Elzy, Wes Aiken, Kevin Job, Rebecca Colby, and especially to Rogue Brack and Kyle Huber, who were the technicians in the year 2023 and really helped me get some new eyes on scales and see different perspectives when we were creating the training manual. And with that, I will take any questions.
Thanks so much for joining us today, Jackie, and for the great presentation. Folks, if you have questions, raise your hand or answer it into the Q&A box, and we will get to those. Jackie, I think we had corresponded recently and was wondering, yes, is it possible for others to have access to that manual that are interested in looking at, giving it a read? And if so, is there a way we could send that out through the forum?
Yeah, so we are currently in the works of getting it published through the USGS science reports that they have. So we will have the first main part of it will be the report with all of our results specifically from this 10-year data set from Fish and Wildlife. And then it will also include the training manual itself incorporated into it. So right now it's in the peer review stage, but we'll hopefully continue keeping that ball rolling, and I can definitely let you know once it's live.
Yeah, please do, and we'll send that out to folks on the forum. Are there? I'm wondering if there's folks in the audience who maybe have difficulties with scales who could see value in this, or maybe your program doesn't. Maybe your program solely relies on OLIS and you're interested in expanding to scales and see this as a potential resource. So certainly would folks, have any comments along those lines, would be interested to hear them. Wes, I see your hand is raised.
Yeah, thanks, Jonathan. Yeah, I think, we've struggled with this for a long time, trying to get consistency along aging methodology and things like that. And one of the things that came out of those workshops was using similar protocols. That was a big takeaway from the 2014 river herring aging workshop. So I think there's value in both, right? I think the OLIS is, gives you better age estimates, and then we get that repeat spawn marks with the scales. I guess I had a question for Jackie is, did you guys only look at the scales on microfiche, or did you actually use some digital cameras?
Yeah, so we were just working with the microfiche that we had.
Yeah, it'd be interesting to see, if you got any better precision or agreement using better technology. I know there's lots of state agencies that have switched over to digital scopes, and that's what we use here. And we noticed a big difference just in being able to manipulate the light through the scale. When you showed that picture of that one scale with all the spawning marks, excuse me, with all the spawning marks stacked up. When you have a stage and a mirror that you can manipulate light, that actually helps quite a bit. So anyways, just throwing that out there.
Yeah, right now the training and test set that we do have, they're all mounted on glass slides. So that's kind of what we are promoting to be used with our feature technicians, but actually digitizing those and making them accessible in a larger platform is a really great resource to have too, in Avenue.
We have another question here from Wilson Laney. I think James will unmute you. Should be able to ask it.
Yeah, you should be able to unmute on your end now, Wilson.
Okay, thank you, Jonathan. Got it. Jackie, I was sort of following up on the previous speaker there. What proportion of the scales did you all determine were difficult or unreadable from a spawning check perspective?
So for this specific analysis, we were using scales that came from fish with known ages, again, using our biologist here that does all of our aging to use that further in our incorporation with survey year. So for the most part, we were looking at scales that had at least one reader saying one thing and the other reader saying the other. So we didn't incorporate scales that were regenerated or that readers didn't come to at least a definite number on.
Okay,
If that
thanks.
answered your question. Yeah.
Yeah, that gets at it. Yeah, and you had said that it was the older fish that were the most problematic, which is what you would expect, I guess. Did you ever find, and I don't know, were you looking at multiple scales from an individual fish and then picking out the most readable one? And did you find, if you were doing that, did you find that there was a lot of variability in scales from an individual fish as well?
Yeah, so this is something that we tried to tackle within the manual itself, trying to make criterias for future technicians to follow. One of them being you want to see a mark on at least half of the scales that you have present. So it's common for there to be at least 8 scales on your slide that you're looking at. So looking for both the frequency, is it in the same place on all of these scales? So at least looking for it on like 4 of the 8 scales is something that we tried to propose as a criteria to work off of. Thinking about precision again with those older fish, I know one workaround that actually kind of flip-flops the results is using this indication of virgin versus repeat. So instead of still having our readers identify how many spawning marks that they're seeing, but when we actually incorporate it in, just making sure that readers both said at least one, then we can just classify that fish as a repeat spawner and then looking at it that way, because it's easier for 2 readers to be able to say that there's at least one spawning mark compared to it actually flip-flops for our 3-year-old fish, where it's like, is this a virgin fish, or 3 and 4-year-old fish, where readers are kind of going back and forth about whether or not they're seeing that first mark. So it lowers the precision in those younger fish, but increases it for our older fish.
Okay, thank you.
It
Sounds like you guys have done great work up there, and I'll look forward to that manual coming out. I think that's going to improve things along the whole coast, although it would be interesting also to know if there's, a lot of difference between the South Atlantic fish. I guess a lot of those don't repeat spawn. They die after their initial spawning run. But for the ones that do repeat spawn, it would be interesting to know if there's a lot of difference between South Atlantic and Northeast and New England fish as well. Thank you so much. Great presentation. And I look forward to the manual coming out.
Thank you. And I will say that I think that was one of the conclusions that did come out of these past aging workshops, was that we have a bunch of states coming together, and these fish can be pretty river specific sometimes, and their life histories might be a little bit different with the amount of stress that they're feeling, and maybe spawning marks are more prominent in different systems. So yeah, there's a lot to keep diving into and trying to, when we talk about standardization, there's a lot of discussion that needs to go into it.
We had one more in the Q&A. This is maybe an easy one for you, talking about the target area to choose scales from. So I don't know if you want to address that one real quick. And
yes, the way that I had identified it is just kind of looking at past protocols. We definitely use the Mass Age and Growth Lab protocol as kind of our gold standard, and I know a lot of states have also kind of adopted it, as Wes was mentioning before. So yes, we've been targeting below the dorsal fin, above the lateral line, as just an area to try to uniform. That's where we're taking them from. I don't know if I have the best answer on why specifically scientifically, if the spawning marks are stronger there, but yeah, I can look further into that.
yeah, thanks. Thanks so much for coming to present, Jackie. Really appreciate you sharing the results of your thesis and all the great work you were doing up there at UMass. So please keep us abreast of any publication there on the manual.
Yeah, thank you for having me.
And at this point, we'll move into our general updates. We have 2. The first one, moving up the coast to the Kennebec River. from Brian Dieterman, University of Southern Maine, looking at the ecology of juvenile Eocene in that system. So Brian, I think you've got some slides. Go ahead and share your screen and we'll jump right in.
All right. So my name is Brian Detterman, and I'm a master's student at the University of Southern Maine, working with Karen Wilson in the Aquatic Systems Lab. And this is about the juvenile Alocene ecology in the Kennebec River. We're working in coordination with Craig King at Maine Department of Marine Resources and Justin Stevens, who it says Maine Sea Grant on there, but he just recently moved over to the Department of Marine Resources as well. And this is year one of a 2-year grant under the Maine Sea Grant. So we can go on to the next slide. And so this study, we're looking at the 3 species of Alocenes that we have here in the Kennebec. That's the American shad, blueback herring, and alewife. We're looking at juveniles. We're looking, the 3 objectives are kind of to characterize the diets and trophic position, looking to infer habitat and resource needs. And we're doing that using stomach contents as well as stable isotope analysis. We're looking to estimate the age and growth using otoliths, and also to look into their migratory behavior using stable isotopes in that way as well. You can go ahead to the next slide. And so like I said before, this is in collaboration with the Department of Marine Resources and their juvenile Alocene and striped bass beach seine survey that's been going on in the Kennebec for over 40 years now. And the goals of that are to support the management of the commercial river herring harvest, as well as the recreational shad fishery. And so one of the really cool things about working on the Kennebec River is this is a really big system. And in our study area, there's really 4 distinct habitat types that we're looking at. In the top left, you can see is an area that is non-tidal freshwater river. And then when you get to Augusta, it becomes a tidal freshwater river. And then moving down the river from there, we have a super unique feature, Merry Meeting Bay, which is a freshwater tidal bay. And then finally, there is a tidal brackish estuary. And so all of those together, there's a total of 24 sampling sites, and they're sampled starting at the beginning of July, sampled twice a month through September. So each site gets sampled twice a month for 3 months for a total of 6 times through the summer. Next. And so this is a look here at our catch data from last summer. On the x-axis, you can see the 4 different habitat types, and the y-axis is the total Alocenes caught, and that's all 3 species combined. There really aren't any significant differences in the catch patterns for the species, so we just kind of combined them for simplicity on this graph. And what you can really see here is that the majority of the fish are being caught in both the non-tidal river and the freshwater tidal bay. And that really is just what is being caught in the seine. So it should be noted that the tidal river and the estuary have much wider and deeper channels. So we might not be capturing the entire juvenile populations with the depth limited seine method. And then next, we can see here highlighted that these are the catch in July. So the vast majority of the fish that we're catching here, especially outside of the freshwater tidal bay, are in July. Let's move to the next. We look at the August catch. There's still a little bit of catch in the non-tidal river and the tidal river, but in August, most of the fish still being caught are in the freshwater tidal bay. And as we move on to the next bit, we have September. Very few fish being caught, and pretty much all the ones that are being caught are in that freshwater tidal bay. And so moving on to the next bit, I'll talk a little bit about some of our preliminary diets that we have. And I should note this is very preliminary. We don't have a ton of data yet, but kind of share what we've got so far. And what we're looking at when we're talking about the metric for our diet is the frequency of occurrence. And so that is going to be what percentage of fish diets a certain item appears in. And off to the left, you can see one of the common ones that we have in the upper sections of the river. That's a chironomid larvae, which is a dipteran. It's a midge larvae. And that one is actually a pretty good sample. A lot of the body is still there, even though we're putting these fish on dry ice pretty much immediately after they're being caught. A lot of them are still having the stomach contents fairly digested, and we're just finding head capsules. And that tends to be what we're identifying most, and we're counting based on seeing those head capsules. So looking at that figure, it's kind of simplified. So we only have items that are at least 25% of diets, so that it's not so busy. And then you can see on that non-tidal river and the tidal river section, so far 100% of the diets are containing those dipteran larvae. And so those are the kind of the dominant diet item for alewife up there. I don't think I mentioned, this is just for alewife to show the differences between alewife in the different reaches. And then as we move into the freshwater tidal bay, cladocerans and copepods take over as the dominant items. And then moving down into the estuary, cladocerans kind of drop out and copepods are the dominant item. And moving on to the next slide, we'll look a little bit at the differences between the species. Here we're just looking in the estuary area and the difference between alewife and the American shad. Once again, only items that are over a 25% frequency. And we can see that the alewife still have copepods as the dominant diet item, where American shad have amphipods and mysid shrimp being their dominant diet items. So we're seeing a little bit of some evidence for some resource partitioning between these two species that are so similar otherwise. And then on the next slide, we can see another really interesting bit of evidence where we're finding these Hymenoptera, which are species of flying ants and wasps, and they're only showing up in shad diets, but they're showing up in shad diets across all 4 of these reaches. So it's kind of another interesting thing where these shad are likely feeding on these at the surface in an opportunistic manner, and another little bit of evidence that there's some resource partitioning, some niche partitioning going on between these species. And next here is our otolith. So we're just getting really rolling with our otolith analysis. This picture here is an American shad otolith. It's mounted on a slide using crystal bond adhesive, and we're imaging it under a microscope. And what we're looking at to age these is the growth rings on there. So similar to how you would age a scale or an otolith from an adult, instead of years, we're getting a growth ring for every day. And so this comes from a fish that is 45 millimeters total length. And you can see it's pretty small. The scale on there is 0.15 millimeters. And then we've got 33 daily growth rings on that. And so when we look at the 33 rings and the total length, we can kind of gauge about how much these fish are growing per day. And we can see if there's some differences in the growth patterns in the fish that we're finding in different areas of the river. So more to come on that in the future. And next slide. And so what's next this summer? We're looking to collect invertebrates, especially small chironomids like we saw in those diets in the upper section of the river. And we want to get stable isotopes that match the diet items. This last summer, trying to use some more traditional invertebrate collection methods, we weren't able to get these chironomids, so we'll probably be doing stuff like grab methods, any way that we can to try and get stuff that matches what we're seeing in the diets. We also want to try and see if we can characterize those deep water channels where we may be missing some of the population with these depth limited seines. We might try using a larger seine net, and we would like to do hydroacoustic surveys, but that's all really going to depend on what happens with our funding and with equipment availability. We're also going to be doing a bit of more targeted collection of samples and continue processing through the samples. And with that, happy to take any questions.
Thanks, Brian. And appreciate you letting me drive on the slides.
Yeah.
Folks, raise your hands or put them in the questions box. We'll give it a minute. Been a quiet crowd today.
The afternoon doldrums here.
Yeah. No, it's really great to see that kind of pulling together the daily growth stuff and diet work. So you're looking at doing a couple of, like, another round of field sampling, maybe just one or more?
Hopefully just one. And so the Department of Marine Resources is going to do the seine survey either way. So we'll kind of tag along and see if we can fill any, gaps in our data, especially hopefully get some fish that aren't just from July, so we can look into, maybe if there's some diet shifts across the months and as they grow in size.
Sure. Are you doing any, plankton toes to look at differences in like any kind of like selectivity. Basically look at sort of the what's available and then what you find in the stomachs and see if there's any sort of differences there, or is it mostly focused on diet contents? I mean, that's probably a lot of bugs and the degraded benthic or bug samples to pick through already, but didn't know if you were going to look at what was out there more broadly.
Yeah, that's something that Karen and I have talked about, and we would like to if we are able to have the time and ability to get out there and do it. Basically,
sure.
A lot's really riding on funding and availability of equipment for the summer. It's
right.
A lot up in the air for us,
I'm sure others on the call can relate. Well, great. Well, thanks. And yeah, once you wrap up all your analyses and everything, hope you come back and share your findings with us. Would love to see it. So appreciate you giving us an update today. All right.
I think Reed has their hand up.
Oh. Yeah, Reed or Wilson, please go ahead and then Ken.
Hey, thanks, Jonathan. Hey, Brian, on those, that's a fascinating finding about the flying ants and wasps. Those were all juvenile American shad, right?
Yes, all juvenile American shad. It was all in August, and they were anywhere from 45 to about 80 millimeters in total length.
Okay, yeah, thanks. I was going to say that, that's a fairly large prey item for fish in that size range. So yes, that's really, really fascinating. It would be interesting to know if they're doing that throughout the Atlantic coast. Thanks for sharing that.
Yeah, you're welcome. And definitely that was, when we found those in there, those stomachs were full.
And Ken, if you want to go ahead. I'm not sure if you can unmute him.
Yep,
James.
You can be able to unmute now.
Hi, can you hear me?
Yeah.
Yep.
Oh, hey, Brian. I was just thinking that if you haven't talked with Adrian Jordan at UMass, he's been using a purse seine to sample offshore in lakes and ponds. They've been doing it for a number of years. So not that you'd be getting the full water column, but with that purse seine, you can get offshore. And so if you weren't aware of that, just wanted to make you aware, and you can connect with him on that as another sampling gear to get away from the seine.
Yeah, and we have talked to him before, and I know that Karen has used purse seines in Highland Lake before to sample too. So it's certainly something that we can put on our radar if we aren't able to use the hydroacoustics or a bigger seine net, definitely.
Great, thanks.
Thank you.
All right, yeah, good catch on the hands. I missed that. Let me make sure I didn't miss others. Okay, that looks good. Yeah, thanks, Brian.
Thank you.
And we will jump over to Emily Farr from Manomet, who's got an update on their data viewing portal.
Can you hear me okay? And how does that screen look?
Yes, and it looks good to me.
Okay, awesome. Great, thanks. So I'm Emily Farr with Manomet Conservation Sciences, and I have given an update on this project with this forum before, but wanted to share this project with folks and mostly to let people know that it's sort of ready to be out in the world and for folks to start using and adding data to. So this is a platform that we have been developing in collaboration with the Mid-Atlantic Fishery Management Council and College of the Atlantic, Lori Baker and some of her students. And the idea was really to develop a central place for information about shad and river herring returns or counts to be shared, viewed, uploaded, downloaded in one place, kind of coast-wide. So this is sort of the homepage of this platform. And since we last provided an update, my colleague Anne has done some great work developing some tutorials to help walk people through the different functionalities of the platform. And I won't go through the whole thing, but I'll just show one of the primary tabs is this tab on annual counts. So most of the data we have in here so far is from Maine, Massachusetts, and Connecticut. So thanks to those of you that are on here that have contributed data already to help us kind of work this platform out. And there's information available for both shad and river herring, although we definitely have more for river herring at this point. And there's a number of different ways to view the data in these tabs at the top. And then at the end here, there's an opportunity to view and download the full data table, as well as upload data directly to the platform. And so there's a couple of different ways that we've built that out, and we're very much open to feedback and ideas and questions as folks hopefully start to use this. So the idea is to first kind of enter your site with this metadata form, and then there are Google Forms for either annual count data or daily count data, and those are set up primarily to enter 1 year at a time. And so we also recognize that there might be an interest in getting some historical data into this kind of a platform. And so we also have some template Excel sheets just to make that easier to get a consistent format for some of that longer time series of data. So that's kind of where we are with this. And I think that Jonathan or James can share the link with folks in the chat or afterwards. And I'm happy to answer any questions that folks might have.
We did drop the link to the Shiny app in the chat here. Thanks, James. And certainly keeping an eye out for hands. Bjorn asked, how are you getting people to participate in contributing data to this? Is there a general call for data, or how have you been rolling this out?
Yeah, it's a great question. We've been mostly kind of having one-on-one back and forth with folks in Connecticut and Massachusetts and Maine as we were kind of developing this to have some initial data from those northern states. But we are just now starting to try to get more information from further along the coast incorporated. So we're going to be doing some direct outreach to folks, and Bjorn would love any suggestions that you have on ways to best do that.
Yeah, that was kind of my question as well. This is certainly a good group to to put that call out to, and obviously if you have things that you want to share with the forum, we can certainly include in our email distributions.
That'd be great.
So let us know if you've got some sort of canned text that you'd like for us to send out. Happy
Sounds
to do
good.
that. Have you run into any? I guess I'd be curious to hear more about maybe some of the difficulties with compiling. I know you have experience with this on other data sets, but is there anything specific to the river herring and shad data sets you've been working with that have been posing unique challenges in terms of getting them all to sort of play well together in the same data viewer? Just curious how you mash all this data together into one thing, and any lessons learned you have there.
Yeah, I'm sure Anne and Lori, who are both online and have done a lot of the data mashing, can also speak to this. I think, yeah, a lot of the data so far that we've put in has been in different formats. And so a lot of it has been just sort of making sure everything has a consistent format in terms of the types of fields we wanted to incorporate into this. And that's sort of why we ended up deciding to create Google Forms and templates, so that if folks do want to enter their data, that there's a consistent structure moving forward. I know for historical data, that's a lot trickier, but hopefully it makes it easy if you have just 1 year of data to enter 1 year of data. And that's kind of a pretty straightforward task. So we're trying to find the middle ground there, and would be really curious to get feedback from anyone who tries to use the forms or the templates, and just let us know how that goes and if there are issues or challenges you run into.
And then is this, I know you have daily counts. I assume this will kind of be retrospective, maybe looking back at a season or something like that. You're not trying to keep up with, you know, like basically real-time data. Is that correct?
Yeah, that's right. So we have the information about annual counts, so just the total at the end of the season, and then for particularly at this point for main runs, since that's where those of us who developed this are based, we have as part of the Gulf of Maine River Herring Network had been compiling daily count information for a number of runs, and so we have that information in here. And if anyone wanted to add their daily kind of seasonal information at the end of the season, for example, we created space to do that, but it's definitely not intended to be a real-time thing.
Bjorn did have a follow-up about data quality requirements. Are there any sort of screening that you do for it to be accepted into the reporting?
No, so we thought about that, and the way that we left it was just that and we have a note at the bottom of every page that we're not doing any additional QA/QC on the data, and just expecting that the data that people submit will be in whatever format they submit, whatever quality they submitted in. We do have a column for any like notes about QA/QC that was done on the data, as well as contact information, so that if people have questions about any particular site, they know who to reach out to.
Okay, so folks are able to see sort of the metadata about, you know, how the survey is, you know, conducted, and any sort of qualifying things there that they may want to take into consideration when looking at those numbers. Is that yeah. So we tried to, this actually might not have it in some of these, but we did try to have information about point of contact, and I'm having a hard time seeing my screen with the WebEx, but there is also a column in here for any quality control that was done, the counting technique that was done, et cetera. This dovetails in nicely into something that we're kind of trying to carry on, that Ben Hagen started, which is the sort of the weekly report. And thanks to all on this call that contribute to that. But it's, you know, just a handful of sites up and down the coast, trying to just get that real-time sort of provisional data to give folks a sense of how their runs are progressing. And something that we had talked about was it'd be nice to have, you know, like a blurb for each survey, so that you kind of understand, you know, how the, you know, say how the electronic counter is calibrated, or, you know, how often it's validated, or things like that, just to have all, you know, for transparency, to have all that data out there. So have you guys talked about doing anything specific, like trying to come up with like a survey profile or something like that for each survey? I guess it's just in the notes at this point, but.
Yeah, we did talk about that. There is a notes column that I'm trying to remember, let me pull up the metadata form, but when people enter, well, I have to walk through the whole thing, but there is a section that sort of just says, at this point, any additional information or notes you wanted to share about, and I think we had a couple of prompts. So it's sort of at the, where we left it for now was kind of an optional, like any other details on the run. But that's definitely something we've talked about, is it would be helpful to have kind of profiles that were available.
Yeah.
But it's a balance of making it an easy lift and having it be everything.
Right. Miranda asked, said, great work to you and the rest of the Management Partnership team. Will you be prioritizing annual data versus daily data with each outreach rollout, or just taking what you can get, essentially?
Yeah, I think hopefully we hope this is a useful tool for people, and they would see value in adding data from their site, so that we can get this bigger picture across the coast. That was kind of the hope. I think annual data is certainly an easier lift, and that's what we probably would prioritize in the call. The daily data we put in there because we have it for a lot of sites in Maine, and if others find that useful, great. But I think annual data would be probably the priority.
Great. Well, thanks for giving us an update, and glad to see it's live. We'll include the link in the meeting recap, if that's okay.
Thank you.
Yeah, let us know if you want us to send us any text you want to accompany that
Will do.
link. We can send out a blurb to the rest of the forum. We got you. Okay. Well, in that case, we can move on to the open discussions and updates section. So thanks, Emily. Appreciate you hopping on today. And yeah, this is really the opportunity to share, what you've been working on, what you're seeing in your part of the world that may be of interest to the rest of the forum. Ask questions of any of the presenters that you didn't get to get in earlier in the meeting today. Call out any highlights of restoration work going on in your watershed, or anything really of interest to the rest of the forum. So raise your hand, enter it in the chat, and we will call on you. Don't be shy. We have 30 minutes here to really foster that group discussion. So I'm sure folks would love to hear about what's going on in everybody's part of the world. So. I guess I'll ask a question just to start the discussion off. Is there a need for another aging workshop coastwide, and is that something that we want to talk about through the forum, or is that better left off through the ASMFC technical committee? If folks have thoughts on that, just in light of Jackie's presentation. Any improvements that need to be made to the coastwide aging approach that we can help to foster. I'd be curious if folks have thoughts on that. Kevin, get your hand raised.
Is my microphone working?
Yeah, it is.
Fantastic, thanks. Yeah, I think that would be a great idea. We're starting to take otoliths this year. We've been planning on doing this 6 years ago now. I guess it was 6 years ago now. But because of staffing shortages, we just have not been able to. So we're fortunate that UMass and Mass DMF are going to be taking on the otolith portion of this. We're going to be out in the field sampling our scales per usual, but then we'll be passing otoliths their way just because they have more resources available to them at this point in time. So, I think moving forward, everybody else kind of having a more standardized method than let's just keep doing what we're doing. Especially, some of the younger people joining in here weren't around. I know I wasn't for that. I think it was 2012 or 2013. So, I think it would be very helpful standardizing things moving forward, because everywhere I go, it's different. Thanks.
Wes?
Yeah, sorry, I just had a question for Kevin. Is Massachusetts doing that out of the kindness of their heart, or do you guys happen to pay for that service?
It's a collaborative through UMass. Adrian Jordan has I think it's 2, maybe 3 years. I hope maybe somebody on here can speak to this grant, and this will be part of that. So I believe it ends after that, at which point hopefully we have more hands here.
Got it. Thanks.
Yeah, Kevin, glad to hear you guys are expanding your analyses a bit, and interested to hear how that gets off the ground for you. So yeah, it's something James and I will discuss, and I'm not exactly sure how the last aging workshop came together, so folks have insights on that. I mean, I know we have travel is not as straightforward as it once was, but hopefully we can at least get a virtual workshop together or something like that, or at least help folks get together to have a workshop, share resources across states. So I noted as a need, and we'll circle back on how to best go about that, unless folks have thoughts or insights on that.
Just going to say as a side note to that, the 2014 one was specifically for river herring, but the two following it were grouped together with a bunch of different species and then eventually dropped.
Yeah, I think ASMC held an aging workshop for a bunch of different species. River herring and shad, I think, used to be part of that. And then, like Jackie was saying, they were dropped. And I can't remember exactly why. It might have been just there wasn't as many, or they just didn't, they weren't as high of a priority relative to other species.
Yeah, I think it was a mix of that, and I may be mistaken, but I think there is maybe 3 states that kind of participated in the river herring portion itself. So yeah, and there wasn't a whole lot of experience with river herring being high up there on that priority list that you mentioned.
Thanks. Yeah, as Kevin noted, I wasn't around in 2012, so good history there. Appreciate that. Any other updates for the group? Questions? Presentations you want to see at future meetings? Kevin, go ahead.
Yeah, no, just wanted to pass a thank you. I see Bailey Bowden's on here up in Maine. He's one of the alewife harvesters of Maine, and talking with those, we're trying to get to a point here where we can, get back to something similar in Connecticut at least. And talking with, they're essentially run stewards up there, which is really great to see because that's one of the things that we struggle with here is getting, I don't want to say take ownership of a run, but just getting people to be involved at even the most basic level to stop and look. And it is, Maine's got a very unique situation where, yes, there's some runs that are not harvested that a lot of people go to, but, having myself also worked one of those commercial runs on the Union River, it brings everybody in the area, and it, you don't miss things that, we're running around here, 2 biologists and a couple of seasonals trying to cover an entire state. It's a small state, but there's a lot of runs, and we miss things. We know we do. So it's been really helpful to hear their side of things and hear that, I'll be out at 1 o'clock in the morning now trying to make sure a fishway is working because I know something's wrong. Well, they're doing the same thing and they're not biologists. So I just kind of wanted to pass along a thank you. It's been really helpful to kind of hear their side of things up there and moving forward here, kind of giving us, where we hopefully could be again at some point. So yeah, I just wanted to pass that along. I think it's a unique opportunity for biologists to learn things from the other side.
Yeah, thanks, Kevin. I think, obviously Maine has got just a much different dynamic, especially than we have down here in the Mid-Atlantic. It's great to see the level of community engagement and involvement up there. And I agree with you. Would love to see that model expanded. Certainly the model of stewardship expanded, back to other states. Trying to make those species visible and reconnect people to a bit of their cultural heritage there. So certainly appreciate folks in Maine sharing their insights.
Jonathan, on that note, just jumping in really quickly, just that we can provide an update on a future meeting, but we're in Maine. This is Emily speaking, sorry, from Gulf of Maine River Herring Network. We're working on an effort that has been interviewing a lot of the stewards in Maine to document the specific work that goes into stewardship of different runs, the amount of time people are putting in, what support they need and are getting. So we'll be excited to share some of that work once we are a little further along with this forum. Hopefully be useful for other states as well.
Yeah, absolutely. Thank you. Any final updates, questions, comments for the forum? Don't need to hold folks longer than necessary, but happy to hear what's going on in other parts of the world. give it. Oh, Alan, go ahead. And I think James may have to unmute you.
Yep, you can unmute on your end now, Alan.
Thanks. Yeah, I just wondered if, I hadn't seen this week's report yet, but we're finally starting to see some alewife up near the fall line on the Rapp and the James. Have things been slow up and down, like relatively speaking, up and down the East Coast, or are things normal? What was there? I just was curious. I know VIMS, they were getting pretty good numbers of alewife a month ago at the mouth of the Chickahominy, for example, but we're just seeing a few get to the dam and haven't been seeing any in the fishway yet. Are things slow up and down the coast or normal?
Yeah,
I can give Connecticut's
yeah, go ahead,
update. Sorry. Yeah, I actually looked through the numbers as I sent along some of the data a little late. Sorry about that this morning. And I would say we're pretty much average for the temp. So we have about 9,100 fish into Bride Lake alewives currently, but our water temps also just about hit 10 today with the warm rain we had last night. So some years we've had 24, 25,000 by this point. Other years we've had 800, but the one deciding factor there is temperature. And those years that we had those bigger numbers were very similar to now. So you could say we're a little bit below what those years were, but we're a little bit above. I'd say we're pretty much average. We've got a few small numbers starting to tick in, and some of our smaller coastal streams. I just talked to Rhode Island, and they have fish at Gilbert Stewart, which is their first run. It's kind of their Bride Lake. So I'd say at least here we're about average. I don't know if Peter's still on the call there, but it sounded like they had fish out on Long Island now, which is they usually have about the same thing as us. Bride has fish, they have fish. So
yeah, we started seeing fish, I think, around May 10th or so. And it's picked up. That's on Long Island.
Yeah, and then Alan, I don't know that I have any other reports from. I think things are just, the surveys are in like the upper part of the Chesapeake are just starting. And then I need to, I guess, call and bug Wes, unless he wants to chime in here, and also Brian Nealon to see what's going on in the rest of the Mid-Atlantic. But I assume if they've got fish up in New England, they're starting to trickle in throughout the coast, the Mid-Atlantic. And I was thinking just yesterday that a little bit of warmer weather followed by rain, I feel like things will probably pick up in the next week here. So maybe the next week's report will be a little bit more filled out, I would assume.
Yeah, we've sampled above Ashland Mill Dam removal a couple times. We haven't seen any target species yet, but was really hoping to go this week, but the rain we got yesterday was not sufficient. But we're gonna try to go anyway. It's great when it's normal flow, but of course once we get those, we're expecting to see alewife and hickory shad upstream of that dam removal for the first time. So I'm anxious to include that in a report in the hopefully near future. But it's a relatively small river. It's 500 CFS, sort of average in the spring, 400 to 500, and right now it's only 200. It's kind of a it's been a low flow year except for a couple high flow events.
Pat McGrath.
Main focuses.
Pat McGrath has his hand raised. Then I think James will need to unmute him.
Hey, I guess Alan's going to make me talk about the
draw you out.
With that cold spell, we did see a decrease in numbers on the Chickahominy, but this last week we finally saw a good push of alewives, which I'm hoping is a future sign for the Rappahannock, because right now the Rappahannock looks really, really bad for river herring. I don't think we've seen over 10 for either species each week we've sampled. In fact, I think bluebacks were actually I think we had 9 bluebacks last week and only 7 alewives. So I'm hoping the cold just knocked them back pretty far, and hopefully we'll see them next week. Shad looked really good on the Rappahannock, and yeah, other than that.
Well, there's some hope there for you. We just late last week, my crew got into some alewife in Fredericksburg. Not a ton, but I think like 40 alewife from Route 1 to City Dock, and got a few on the James, and they just got a few alewife below Walker's Dam today finally. So yeah, so there are some alewife moving up the Rap. Hopefully they're going to sample again tomorrow. I'll let you know what happens. That's good to hear about the shad on the Rappahannock though.
Wes, you want to speak to what's going on in New York?
Sure. Yeah, we haven't been sampling yet. We're going 2 weeks from today is our first day of sampling. So yeah, we typically don't really start catching alewife consistently until probably like the second week of April. So hopefully we have a good run this year of both alewife and blueback. Last year wasn't very good, so fingers crossed.
Great, thanks. I will call and bug you in 2 weeks if we don't hear from you. Okay, yeah, great. Happy to hear what's going on up down the coast. Alan, did you have anything else you wanted to chime in on?
No, that was it for now. Thanks. Oh, our shad cam is live as of today, and just watching some regular suckers go by. So if you need something to do and you have insomnia, turn on shad cam and just Google shad cam or Virginia shad cam and you'll get it.
Okay, yeah, I'll send the link out. In our in our meeting summary, and we'll see. I need to see if I can get it on the break room around here. There's been a lot of birds on our cam TV in the break room here, so I appreciate you keying me in on that.
Thanks.
Okay, well, great. For those who are still on, obviously, many of you are probably on the weekly reporting distribution, but basically this is, like I said, this is something we've been trying to keep up with. That Ben Gahagan passed over to us. Is just a sort of provisional data email blast that we send out each week. So if you're interested in getting added to that list, send James and myself an email, and we will add you to that distribution. And then for those folks who are contributing data to that weekly report, really appreciate it. I know it's a busy time of year, so let us know how to make that an easier lift for you, how to get in touch with you, if email's best, phone, whatever it is, and then we'll just keep sending out the numbers and the information as we get it. So thank you all for that. And James, do you have anything else to add on for the meeting before we wrap up today?
Nope, nothing to add. And just like you said, appreciate everyone's time again for all our presenters and for the weekly report for the data contributors as well. Thank you.
All right, everybody, thanks. We'll send a summary email out when it's all posted up to the web, and appreciate your participation.
Thank you.
We'll see you in November.
Thanks, Jonathan.
Thank you all.
Thanks, James.
Yep. Thanks, guys.
Thanks.